These are notes for gas law worksheet number 2. Joseph Guy Lussac was a French chemist and physicist. Below he's ascending with Biot in a hot air balloon in 1804. He recognized iodine as an element. He was the co-discoverer of boron, and he coined the terms pipette and burette. His law is concerned with pressure and temperature. It's called Lussac's law. And as temperature increases, the pressure also increases. So it is a direct relationship. P1 T2 equals P2 T2. What happens to the speed of the molecules as temperature increases? And the speed increases, hence the number of collisions increase. We're going to do number 1A from worksheet 2. So let's write down what we know. And that means we may need to grab a pen. So what do we know? Where is our pen? There it is. What do we know? That looks really pretty, doesn't it? So again, this is number 1A. Things we know. T1 equals 122 degrees Celsius. But we can't leave it in degrees Celsius, so we have to add 273 because that's how we get to Kelvin. Always add 273. And that equals 395 kelvins. And T2, I'm already going to add the kelvins to it, is 295 Kelvin. Oops, we got our 5 in there. Our first pressure we don't know because we're trying to find the original pressure, and we're trying to find that in the unit of millimeters of mercury. And the second pressure that we do know is 762 millimeters of mercury. It's great because those units of pressures are the same, so we don't have to do any conversions. The equation we're going to use is P1 T2 equals P2 T1, and we're trying to solve for P1, so P1 is going to be P2 T1 divided by T2. We plug in our numbers. I like to include the units so I can cross-cancel things. 762 millimeters of mercury times 395K divided by 295K. They all have 3 sig figs, so our answer should have 3 sig figs. And that is 1020 millimeters of mercury. That last 0 doesn't count because there's not a line over it or a decimal at the end of it. There we go. Now we're moving on to the next slide. The combined gas law is a combo of Boyle, Charles, and Lussac. It's P1 V1 T2 is P2 V2 T1. And we're going to do number 2A from worksheet 2. Again, we're going to write down what we know. And if I have any degrees Celsius, I'm going to automatically change them into kelvins. So what we do know is that the first volume is 15.2 liters. The second volume we don't know. I'm going to put a question mark there, and what we're trying to find it in is liters. Our first pressure is 1.35 atmospheres. Our second pressure is 3.50 atmospheres. And our first temperature, 1, is 306K. And our second temperature is 308K. And I'm going to look at my units. I have volume, pressure, and temperature. So I'm going to use the equation with P, V's, and T's in it. So P1, V1, T2 equals P2, V2, T1. I'm going to solve for V2. So I'm going to isolate that variable. And that's going to be P1, V1, T2, all divided by P2, T1. Now I'm going to find my numbers and drag them in there and do a little math. I love to keep the units in there to see if they cross-cancel. 1.35 ATM times 15.2 liters times 308 kelvins, all divided by 3.50 atmospheres times, that's in atmospheres, 306 kelvins. So here I get to go. Cross me, cross me, cross me, cross me. Got to cross out those great units. Left with liters, that's what I want. So 3 sig figs, 5.90 liters. Cha-ching! Love it. STP stands for standard temperature and pressure. It is a shorthand notation instead of having to type everything out. So what it means is temperature is always 0 degrees Celsius, which in these calculations is better known as 273 K. And the pressure is always 1 atmosphere, or if it's in millimeters of mercury, is 760 mmHg. Let's do number 3A from worksheet 2. Again, we need to find our pen. Grab my red pen, and I'm going to write down what I know. So what I know for 3A is that volume 1 is 3.50 liters. I do not know the second volume, that's what I'm trying to find, and I'm trying to find that in liters also, which is great. And another thing I know is, let's look at here. I'm trying to find volumes in liters, and I was given that volume, and I have a T1, which is 30 degrees Celsius. If you add 273, you get 303 K. And I know pressure 1, which is 1 atmosphere. Okay, so my second set of temperatures and pressure comes from STP. It makes it so much easier not to type those out. So that means the second temperature is 0 degrees Celsius, which is 273 K. And that means the pressure 1 is 1 atmosphere. Well, this is interesting. Sorry, the second pressure, not pressure 1. The pressures are equal. Now I have to choose an equation from all those equations I've used. I see I have V's, T's, and P's. So I'm going to choose the equation we used last time, which is P1 V1 T2 equals P2 V2 T1. I am going to solve for V2. V2 is P1 V1 T2 divided by P2 T1. I'm going to plug in my numbers, and I notice that my pressures are exactly equal. So I don't need to put them in there. They're going to cancel out. So I'm just going to cancel out my P's since they're equal, and I'm going to plug in my V, which is 3.50 liters, times 273 K divided by 303 K. I'm going to make sure my units cancel out. K cancels out K. V2 is 3.15 liters, 3 sig figs. Number seems reasonable, and that's all she wrote. Those are the notes for worksheet 2. Good luck.